Good evening. Welcome to the QCIS channel, where on this channel you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and this evening I want to get into a little bit of chemistry. And this is my favorite part of chemistry because what I'm going to talk about is the periodic table. Now, when I was going to school and we looked at the periodic table, it didn't look as large as it does now. In fact, when I was going to school, the periodic table only had 103 elements. Now, you look at the periodic table, it has 118 elements. Now, what is the periodic table? Basically, the periodic table is a chart that categorizes different chemicals based on atomic mass and atomic number. Now you have your metals, you have your gases, and these are very significant in chemistry. You deal with neutrons, protons, electrons, they go all into the periodic table. Now, I'm going to share my PowerPoint with you in a minute, but first, I want to give you the real definition of the periodic table. Again, just as I mentioned it, the periodic table is a chart that organizes all known chemical elements into rows, periods, columns, groups based on their atomic number, which is the number of protons in an atom's nucleus. Now, this arrangement reveals patterns and trends in the elements' physical and chemical properties, which repeat in a periodic way. Now, this was developed by Dmitri Mendeleev, and it serves as a fundamental tool in chemistry and other sciences, to understand and predict the behavior of elements and design experience. Now, the key aspects to the periodic table. Again, we look at the atomic number. Remember, elements are ordered by increasing atomic number from hydrogen, which is 1, to the most recently discovered elements, currently up to 118. And then you have the columns, or we call them groups and families, and they're elements within the same column, and they have similar valence electron configurations and therefore exhibit similar chemical properties. Then you have periodic trends. That's the table's structure, highlights recurring patterns or trends in an element's properties, such as electronegativity and atomic radius. Then you have color coding. That's color coding. Now, many periodic tables are color coded to represent different types of elements like metals, nonmetals, or to display other information. And then you have your information display. So basically, each element's cell typically shows its atomic number, chemical symbol, atomic mass, and other relevant information. And then the purpose and importance. Well, we look at the organization of elements. Why? Because it provides a clear and organized framework for the 118 known elements, which are the building blocks of all matter. Then we have predictive power. The periodic trends it shows allow scientists to predict the properties of undiscovered or newly synthesized elements. And then we have the scientific understanding. It's a cornerstone for understanding the relationships between elements and their chemical behaviors. And then we look at the educational tool, and that's basically the periodic table is used widely in education to help students learn about chemistry. This is why I love the periodic table. Why? Because again, just as I mentioned it, the periodic table is used widely in education to help students learn about chemistry. For instance, if you are in environmental engineering and you're about to take the FE examination, where you're going to see hydrogen, you're going to see hardness of materials, you're going to see water, you're going to see metals. And this is where the periodic table has its advantage. Now, I'm going to get into a PowerPoint and we're going to get into the periodic table. Now, when we deal with the periodic table, what are we talking about? Pure substances. Now, pure substances are made of only one kind of matter and has definite properties. We look at elements. Well, elements cannot be broken down into other substances by any physical or chemical means. And then we look at compounds. Well, what's a compound? A compound is a substance made of two or more elements that are chemically combined. Let's show an example. And these are very common. Water. Now, what is water? Well, water, you have two hydrogens and one oxygen. So if you put them together, what would the atomic mass unit be? It would be 18. Then you have carbon dioxide, CO2, one carbon, two oxygen. I believe carbon is 12 and oxygen is 16. So you have 12, you have carbon dioxide, oxygen is 2, so 32, 12, 44. And you learn all that on the periodic table. Now, particles of matter, or the atom. Why do we care about the atom? Well, the atom is the smallest particle of an element. Then we have the atomic theory. John Dalton formed the basis of our understanding of atoms. And then we break it down to the molecule. And a molecule is basically a particle of a compound, a group of atoms that are joined together to act as a single unit. A structure of an atom. And see, this is where you're going to get the building blocks of the periodic table when we deal with neutrons, protons, electrons. Well, when we deal with the nucleus, and this is basically when we look at the atom, the nucleus is the central core of the atom. It contains protons and neutrons. Now, remember something about protons. Protons are positive where neutrons have no charge. Now, electrons are negative, and what electrons do is they move around the nucleus. And atoms are neutral. Why? Because electrons and protons are basically equal. And under atoms, most of the mass is in the nucleus. Most of the volume is in the space where the electrons move. Now, not all electrons are the same distance from the nucleus and don't have equal strength. So, when we talk about electrons, we deal with valence electrons. Valence electrons that are the farthest away or most loosely held number of valence electrons determines many properties of the element. And the element is an atom. Then we get into the periodic table. As I mentioned it before, Mendeleev recognized a hidden pattern in the elements and wrote facts about properties. Notice patterns when elements were arranged in increasing atomic mass. Now the periodic table, and here's what I'm talking about. So we have the atomic mass, and basically the average mass of one atom of the element. So basically we have protons, and that equals 1 AMU. Now, what does AMU stand for? If you don't know, AMU is atomic mass unit. So a proton has 1 atomic mass unit. A neutron has 1 atomic mass unit. And electrons have no atomic mass units. So now we deal with the atomic number. That's the number of protons in the nucleus. And the atomic number identifies the element. And remember, the periodic table is arranged by atomic number. So when we look at the periodic table, we look at the atomic number, the chemical symbol, the name, and the atomic mass. We also look at the groups. The groups are the elements in a column, families, group 1 to 18. There's also a family name based on first element in a column. There's similar characteristics and have same number and arrangement of valence electrons. We have periods, which are horizontal rows. Periods are horizontal rows. Again, periods are horizontal rows. And they also have elements from different families, not similar properties. In fact, the last element in an inactive gas is also in a period. You also have reactive and unreactive. You have 7 periods. And the valence electrons increase from left to right across a period. Then you have what we call a Bohr diagram. Suggested electrons move in a set path. Each electron has a certain energy that is determined by its path, and it must gain energy to move to a higher energy level. Now, if you see my background, the background of this video shows the periodic table. You have the Lewis structure. And what's in the Lewis structure is it's the chemical symbol for the element. It's surrounded by the number of valence electron present in the ion. So remember, atoms will gain or lose electrons in order to achieve a stable noble gas. That's group 8, electronic configuration. Then you have negative ions, which are anions. Ions are anions. Remember, and I saw this on the FE exam, and I couldn't get this right to save my life. And now I remember, again, now I remember when you have a negative ion, that's called an anion. So for all of you taking the chemical or maybe the other disciplines and the environmental examination, you're going to have some chemistry. You better know this. They're going to have ions on there. They're going to have covalence, bonding. It's all on that FE examination. So you remember, ions, which are negative, are anions. And they're formed when an atom gains electrons. Then you have cations. Cations are positive ions. They're formed when an atom loses electrons. Again, cations are performed when an atom loses electrons. Then you have your electron shell. So for your first shell, it's 2 electrons. Your second shell is 8 electrons. And your third shell, up to 18 electrons, although considered full if it has 8 electrons. You have your metals, which are physical properties. So you have hardness, shiny, malleable, ductile, good conductors, magnetic, most solid at room temperature. You will find this in mechanics of materials, and you will also find this in materials science, the physical properties of metals. Then you also have the chemical properties as well. And chemical properties deal with reactivity, and they vary amongst metals. Metals in a group have similar properties and change gradually across the table. Then you have your alkali metals, group 1. So reactive never found uncombined in nature. And also alkali metals are soft and shiny, and there's only 1 electron in the outer shell. Then you have alkaline earth metals, group 2. reactive, but less reactive than group 1. They're hard, good conductors, and you have 2 valence electrons. Then you have your transition metals. Group 3 to 12. So similar to each other that the difference between columns is hard to detect. They're hard and shiny, fairly stable, and they're also good conductors. Then you have metals in mixed groups. That's group 13 to 16. Contains metals, nonmetals, and metalloids. Not as reactive, lanthanides, actinides, rare earth metals, fit between periods 6 and 7. Now, lanthanides, soft, shiny, malleable, good conductors. Now, what do I mean by malleable? Something's malleable can break easily. Then you have your actinides, TH and U, natural. The rest are artificial, synthetic, unstable. And you have your nonmetals, lack properties of most metals, located to the right of the zigzag line in a table. Physical properties, nonmetals, gases at room temperature, low boiling points, dull, brittle. When something's brittle, once you put some stress on it, it's going to break. Poor conductors, lower densities. Chemical properties, nonmetals, most readily form compounds, group 18. No, because they don't gain or lose valence electrons. Nonmetal can combine with metals. Example, salt. Now, what is salt? I'll tell you what salt is. Salt is NaCl, sodium chloride. Nonmetals can combine with other nonmetals by sharing electrons, and that's where you get salt from. Families of nonmetals. The carbon family, group 14, 4 valence electrons, 1 nonmetal, 2 metalloids, 2 metals. Then you have your nitrogen family, group 15, 5 valence electrons, 2 nonmetals, 2 metalloids, and 1 metal. Families of nonmetals, you have your oxygen family, group 16, 6 valence electrons, gains or shares 2 electrons when it reacts. Then you have 3 nonmetals, 1 metalloid, 1 metal. Then you have your halogen family. Now, what is something very common where you see halogen? If you guessed your headlights, that's right, halogen bulbs. They're your headlights. Group 17, all metals, but 1, 7 valence electrons. They gain and share 1 electron, and very reactive. Families of nonmetals, noble gases, group 18, 8 valence electrons, don't share, don't gain or lose electrons. They're unreactive, they're chemically stable. Then you have hydrogen, simplest element. Chemical properties differ from all other elements. And metalloids, on the border between metals and nonmetals. Some characteristics of metals and nonmetals. Si, the most common. Of course, metalloids vary in conducting electricity. Now, what is Si? If you guessed it, you're right. Silicon. That's Si. Now, I didn't show it, but if you look in the back of me with the periodic table, you see this 13, 14, 15, 16, 17. They're the groups. When we deal with the periodic table, there are 18 groups, and you can see the colors. You see the red, you see the kind of orange, yellow, some green, purple. Now, something you need to know about the periodic table, because I mentioned it earlier, 4 big items. So you'll understand what you're looking at when it comes to an element. I'm going to go to this one right here, B. B is boron. Now, 4 things you need to know when it comes to looking at an element in the periodic table. You need to know its atomic number. You need to know the chemical symbol. You need to know the atomic mass, and you need to know the name. And I'm going to show you right now what boron is. So you have this 5 right here. 5 that's the atomic number. The chemical symbol is B. Then you have the name, boron. And then you have 10.81. That's the atomic mass. This is what you're going to use. In fact, if you're doing any dissolution or dissolvents, you might look at atomic weight unit. You might look at grams, moles. You might use some of these elements to convert dilution from one to another. And this table will help you. Now you can see the table behind me has 118 elements. Again, when I was coming up, it only went up to 103. Now it's all the way up to 118. And again, the numbers right across, these are your different periods. And it's also color coded. So, again, when we deal with the periodic table, so you know exactly what I'm talking about as we break everything down. Periodic table is a chart that organizes all chemical elements into rows or periods and columns or groups based on their atomic number. And if looking at it right here, so you see it right here. This is your atomic number, 1 in hydrogen. This is your chemical symbol, H for hydrogen. This is the name, hydrogen, and your atomic mass unit. That's what that is. So when we deal with the atomic number, we're dealing with the number of protons in an atom's nucleus. Nucleus has the largest mass. So this arrangement reveals patterns and trends in the elements' physical and chemical properties. Notice we said physical and chemical properties. Now there are also mechanical properties, but that's in material science. In fact, you go back and look at my material science, there are chemical and electrical properties as well. But basically, we're looking at the patterns and trends in the elements' physical and chemical properties, which repeat in a periodic way. And again, this was developed by Dmitri Mendeleev, and it serves as a mental tool in chemistry and other sciences to understand and predict the behavior of elements in a periodic table. Now, again, to go over it again, the key elements of the periodic table, we have the atomic number. I just mentioned it to you. Elements are ordered by increasing atomic number from hydrogen, which is 1, to the most recently discovered elements, currently up to 118. We have our rows or periods. Elements in the same row share the same number of electron shells. Then we have our columns, or we call them groups or families, some people. Elements within the same column have similar valence electron configurations and therefore exhibit similar chemical properties. And then we look at periodic trends. That's periodic trends. The table's structure highlights recurring patterns or trends in an element's properties, such as electronegativity. Again, that's electronegativity and atomic radius. And I just mentioned about the colors, color coding. Well, many periodic tables are color coded to represent different types of elements like metals and nonmetals, or to display other information. And then we have information display. Each element's cell typically shows its atomic number. This is very important. The information display, that gave it to you. The atomic number, the chemical symbol, the atomic mass, and other relevant information. The other relevant information is the name of the element. And then it's very important, and there's a purpose behind this periodic table. We deal with the organization of elements. It provides a clear and organized framework for the 118 known elements, which are the building blocks of all matter. Then we have predictive power. The periodic trends it shows will allow scientists to predict the properties of undiscovered or newly synthesized elements. And we have scientific understanding, where it is a cornerstone for understanding the relationships between elements and their chemical behaviors. And of course, periodic table is an educational tool, and it's widely used in education to help students learn about chemistry. And there you have it, giving you an overview of the periodic table, just like the one in the background where you see all of the elements, the information that I've given you. So now, when you look at the periodic table, you will know exactly what you're looking for, because you're going to need these elements when you have to balance equations as well. You're going to need these elements when you're solving for reactants and productions. You're going to need these elements when you're mixing chemicals. You're going to need to understand the metals. You need to understand the gases. You need to understand the newer elements as well. Now, the newer elements, basically, I'm going to say from 104 all the way to 118, they're the newer elements. And just understand what they are. Now, another question would be, what would the periodic table look like if more elements were discovered? I mean, there could be a 119 and a 120. Where would you put it? What would it be? That's something to really think about. Because I remember when the periodic table went all the way to 103, in fact, it used to stop at, because 89 to 103 is, got a number at the bottom here. There was no 104 to 118. So would the periodic table change? What would the atomic mass unit be? I already know what the atomic numbers would be. What would the chemical symbol be? So those are questions that you can ask yourself. But overall, if you want a good education in chemistry, you're going to see this on the FE exam. Understand it very well. In fact, this periodic table is in the FE reference book. When you get to your chemical section, you're going to need to know it, because you're going to have to do some dissolvent problems. You're going to have to do some mold problems. So you need to know how, let's say you have SO2, which is sulfur oxide. Well, you have to look up two elements, find out what the weight is. That's how you use this periodic table. So that concludes this topic on the periodic table. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some news and some social topics, check out my main channel, the 411 Talk Zone radio show channel. Now, here's where you can find me For the 411 Talk Zone radio show channel, you can find me on YouTube. You can find me on X, formerly Twitter. You can find me on Rumble and Truth Social. And for the QCIS channel, you can find me right here on YouTube. You can find me on X, formerly Twitter. And of course, you can find me on LinkedIn. Once again, thank you for listening and viewing this content about the periodic table right here on the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.